Objectives for section 1.5. Woohoo! Okay, so we have quite a few objectives here. Some sections are going to have this many, some will have more, but these are all pretty important stuff of ways to solve quadratics. So let's get right to it. Solving quadratics by factoring, solving quadratics by the square root property, solving quadratics by completing the square, solving equations using the quadratic formula, use the discriminant to determine the number and types of solutions, and determine the most effective method to use when solving a quadratic equation. Do any of those words sound familiar to you? Any words besides solve? Okay, good. Factoring? All right, awesome. Let's start with that. Okay, so let's start with the first one, solve quadratic equations by factoring. So here's how we talked about factoring in Algebra 2, and it's the same in college algebra. Okay, if you have a trinomial like this with a leading coefficient of 1, do you remember how to do this? We have to figure out what multiplies to be the last term. Perfect. Adds to be the middle term. Okay? Can you think of two numbers that multiply to be 10 and add to be negative 7? 2 and 5. What kind of 2 and 5? Negative 2 and negative 5. Okay? Now, most of the time it'll equal 0. And if it doesn't equal 0, you're going to want to make it equal 0. Okay? Because then, if I have two things that multiply together and it equals 0, at least one of these has to be 0, right? Which one? I don't know either. Okay, so we just set them both equal to 0. Okay, the property, I want to show you this though. Okay, the property that we're talking about actually says if A, B equals 0, then either A equals 0 or B equals 0 or both. Okay, so we don't mess around. We don't try to figure out which one it is. We just think both of them are and go from there. So these are our solutions. Are they both correct in this situation? Well, what's 2 squared? 4 minus 14? Negative 10 plus 10? 0. So that one for sure is correct, right? What's 5 squared? 25 minus 35? Negative 10 plus 10. 0. So yeah, for sure they both work. Okay, but I do want to remind you about this as well. Okay, I don't have one written down, and it will take me just a minute to figure it out. So we're going to do this problem again. All right, but what if the leading coefficient wasn't 1? We can still do it. Factoring just may or may not be the most effective method, which is one of our objectives that we have to talk about in a little while. We might as well talk about it as we go. Okay, but we can do. I'm going to remind you of the other way we can factor trinomials like this, just in case the leading coefficient's not 1. Okay, that's when we do AC. Well, what is A times C? That's 10. And what's B? Negative 7, right? So same kind of thing, we say what multiplies to be AC and adds to be B. Well, that's negative 5 and negative 2, right? When we're doing this way, we split the middle term into two parts, negative 2x and negative 5x. We still have our first term and we still have our last term, and it still equals 0. Now I have 4 terms and I can factor by grouping. If you guys remember that was something you were really good at in Algebra 2, was factoring by grouping. What's common in these first 2 terms? An x. When I factor it out, I get x minus 2. What's common in the second 2 terms? A 5, but keep in mind I want my parentheses to look the same, so I need to really factor out a negative 5, right? When I do that, I'm going to get x minus 2. Now, what's common in these 2 terms? X minus 2. When I factor it out, what's left? X minus 5. Now, I just want you mostly to see that we got the same answer. Okay, we did get to the same answer, but this is the skill that you need. These are the steps you need to remember if this leading coefficient is not 1. Okay? And then, of course, set each one of these equal to 0 and solve. And we know what our answers are because we already got them. Okay? These are called, just so we're clear, these are called the solutions. And these are called the factors. That's not all they're called, but those are some things that I want you to really know. Okay? Okay so far? Okay. Now, some other factoring that we can do, some other ways we can solve quadratic equations are by using the difference of squares. Okay? If we solve the difference of squares, it'll look like this. Or it might look like this. Do you see why those are called difference of squares? Difference because of the minus, squares because each one of these numbers, each one of these 4 numbers in these 2 separate problems are squared numbers. You could take the square root of them, right? So to get them factored, when we're factoring the difference of squares, we take the square root of the first and put it at the beginning. We take the square root of the last and put it at the end. And then tell me about the signs. What do you remember? Yep, they're opposite signs, right? One's plus and one's minus. And then we're done, and then all we have to do is set each of these equal to 0 to get the solutions. But these are the factors, right? What about this one? What would we write for this one? 2y and 7. And then opposite signs, plus and minus. Got that? So that's the difference of squares. So that's the first one that we're going to talk about. Second one we're going to talk about is the sum of squares. This one's my favorite, just for the record. Okay, sum of squares looks like this. X squared plus 9. Ready to factor it? Done. That's why it's my favorite. It's prime. So we're done. We can't factor it. Okay. There's other ways that we could solve it, but solving it with by factoring is not the way that we can choose. Okay. Then we have the sum and difference of cubes. Do you remember anything about that? Okay. That's all right. That's okay. A cubed minus b cubed. Maybe you'll remember some when I start writing it down. That happens a lot to you, doesn't it? Maybe not a lot, but more often than not, right? Okay, so you're going to get a binomial and a trinomial. Does that look familiar? What's the cube root of the first term? What's the cube root of the last term? B. Now square this first term. A squared. For the middle term of the trinomial, you multiply these two together. And then for the last term in the trinomial, you square this one. Now, do you remember anything about the signs? Whatever sign was in the problem goes in the binomial. The next sign is opposite of that, and the last sign is always plus. But here's the fun part. To do the sum of squares, you already know it, because it looks like a plus. The pattern is all the same except for the signs, right? Whatever sign was in the problem is the sign that goes in the binomial. The next sign is opposite of that. The last sign is always plus. The skills are the same though. Okay, it's just the signs that you have to watch out for. Any questions on that? Okay, so that's quite a bit of factoring in just a couple examples. Is that all the factoring you're going to have to do? Probably not. Okay, but those are some really great examples to be able to look back at as well. All right. Number 2, objective number 2, solving equations using the square root property. These are the ones you guys typically like because it looks like this. 3x squared minus 15 equals 0. What do I do first to solve this? Yeah, there's only an x squared term. There's not an x term at all. And when there's not an x term at all, that makes it really, really nice. Because we do add 15, just like you suggested. And we get 3x squared equals 15. We divide both sides by 3 and get x squared equals 5. Yep, square root both sides. X equals square root of 5. I don't know it. Do you? Okay, so we can just leave square root of 5. But if you put that in, it's not going to be right. Okay? You don't have to put it in. You don't have to put it in your calculator and get a decimal. This is only half the answer. What if this was actually 25 right here, and I took the square root of both sides? What two numbers multiply together to give me 25? 5 and 5. What else? Have to be the same number. What'd you say? -5, -5, right? So we have to remember to put the plus or minus. We put the plus or minus sign, or excuse me, we put the root sign into the problem, so we have to put the plus or minus sign as well. Does that make sense? Okay. So if we had something like this, some people's first reaction is to go ahead and multiply this out. Right? Here's a new problem. Some people's first reaction is to multiply this out. I don't want you to multiply it out, because this thing is being squared. How can I get rid of that? Yeah, square root it. Boom, boom. X minus 2 equals plus or minus the square root of 6. How do I solve for x? Yeah, perfect. Yes, I'm going to write it in this order. The other order is not wrong. Here's what you said. That's what you said. Okay, it's not wrong. The problem is sometimes you're going to get writing fast on your paper, and this is going to creep over, and then is the 2 in or out? You have to go back and look. You know what I'm saying? So you just got to be careful. You can write it that way as long as you're careful. It should be correct. Any questions about that? Okay. Our next objective we want to talk about is completing the square. This is something, when I first learned it, I was not very good at. And then I realized it was like a puzzle, and then I got really good at it, because it's just a puzzle. And I like puzzles. Starting off, just remembering, starting off real basic here, x squared plus 8x. If that's what you're given and asked to complete the square, you're asking for a third term. You're asking to complete the square, which is a trinomial. Okay? Do you remember how to complete the square? Do you remember what number goes in this blank? Divide this by 2 and square it. What is 8 divided by 2? 4 squared? What if it was x squared minus 10x? What number is going to go in the blank? Close. Very close. What's negative 5 times negative 5? Positive 25. Okay? So, will we ever subtract a term right here? No. Because anytime I divide this by 2 and square it, anytime I square a number, it's going to give me a positive value, right? Okay? What about this? X squared plus 3/5 x. What number is going to go in the blank? Well, I have to take 3/5 and divide it by 2, but dividing something by 2 is the same thing as multiplying it by a half, right? So if I multiply this by a half, I get 3/10, and then I have to square that to be able to fill it in the blank, right? What is that? 9/100. Okay, remember when we square a fraction, we square the numerator and we square the denominator. Okay, now if we get a problem like this, is that, you think, the most efficient method to use if this is what the problem looks like? No, probably not. Okay, now if they give you this problem and say complete the square, you're going to say yes ma'am and do it, right? But if it's saying solve a quadratic, I probably would definitely, actually not just even probably, I definitely wouldn't use completing the square here. Okay, it's not the most efficient use of my time or my skills. Okay, So let's solve a problem, like solve an equation using completing the square, now that we remember how to do it. Here's what one of the problems might look like. Okay? So up here I had an x squared term and an x term, and I had to fill in the blank, right? Well, in this problem there's an x squared term and an x term, but then there's this other nonsense term. What do I need to do with that? Yep. I need to get rid of it, move it to the other side of the equation. But when I move it to the other side of the equation, I'm going to leave myself a space right there because I know I'm about to fill in the square. I'm going to complete the square, right? So what term is going to go right here? Well, how did you get 9? 6 divided by 2 squared. Perfect. Plus 9. I have now significantly changed the problem, and that's bad. I added 9 to one side of the equation. Yes, I do. I have to add it to both sides of the equation. Okay? Sometimes I give myself a blank, like here, just like I did up here. And when I do, I give myself a blank on both sides because I don't like to leave blanks. So I remember to fill in the blanks. You can do that or not. It's up to you. Okay? Now, this is a perfect square trinomial. I want to take it down to its binomial. Okay? What's the binomial if this is the trinomial? Well, I know that's an x, right? Because of the middle term, I know it's a minus. What's this second term of the binomial? Well, just as a reminder, it's either half of this number or the square root of this number. That will be the same, won't it? Half of 6 is 3, the square root of 9 is 3. Okay, that's a good way to remember it. Equals what? Good, 5. Now how do I solve this? Well, I'm going to solve that the same way that I solved this other problem over here, right? Yeah, perfect. Square root, square root. So x minus 3 equals almost, plus or minus the square root of 5. Yeah, add 3 to both sides. X equals 3 plus or minus the square root of 5. How do you feel about that? Now, there are going to be times where they give you problems and they tell you to complete the square, which is really what you need to do, and the problem looks like this. Okay? If I'm told to solve this equation, I'm not going to choose completing the square. Because first of all, my leading coefficient is not 1. I really got to have a leading coefficient of 1 to be able to complete the square. Okay? I would probably do something else, but if they give you an equation like this and tell you to complete the square, I need you to know how to do it. So the first thing we're going to do is get rid of that 9. We're going to divide every single term by 9. Okay? Every term on both sides. So I end up with x squared minus 2 over 3x minus 4 over 9 equals 0. Okay, so far? I need to get rid of this the third term on both sides, add it to both sides, So I have x squared minus 2/3 x equals 4/9. How do I complete my square? What goes in there? 2/3 times 1/2, right? Which is 2 over 6, 1/3, right? Because those can simplify as well, right? So 1/3, and then I square that, 1/9. And I add that to both sides of my equation. I take my trinomial and write it as my binomial. X minus what? Either half of this or the square root of this. 1/3 equals 5/9. How do I solve it from here? Good. X minus 1/3 equals plus or minus the square root of 5/9. Now I'm going to give you a heads up. Your computer program will not like you to leave it like this. It doesn't like square roots in the denominator. Okay? So I want to remind you that these are the properties of square roots, that you can separate a problem like this into a problem like this, which means I can simplify that to the square root of 5 over 3. Does that make sense? Does everybody see where that came from? Okay. So if I add 1/3 to both sides, I have x equals 1/3 plus or minus the square root of 5 over 3. Depending on how, I don't know if it's just moody, your computer is moody sometimes, or I don't know if it just, the people that put in the answers only put in one possibility. I don't know. Okay. This is a possible answer, but so is this. I need you to make sure that you see where both of those answers came from. Yes or no? This one has a common denominator, so I can just combine the numerators and keep the denominator, and this one has them separate. You okay with that? Again, I probably wouldn't use completing the square if that was the problem, unless it told me that that's what I had to do, and especially if it told me to do it and made me show my steps. You know what I'm saying? Okay, next one, solve quadratic equations using the quadratic formula. You know that that's my favorite way, right? Because we get to sing. You remember the quadratic formula? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm so proud of you. Excellent. Okay. Do I need to do any examples of that, or you guys got that okay? Okay. Here's what I do want you to remember. Do you remember what that is called? That's the discriminant. What the discriminant will tell you, that's one of our objectives for the day, using the discriminant to determine the number and type of solutions. Okay, the discriminant has 3 possible things that it can be. It can be positive, it can be 0, and it can be negative. Those are the only 3 possibilities, right? If the discriminant is positive, you're going to get 2 real solutions. If the discriminant is 0, you'll get 1 real solution. Now, if you'll remember the fundamental theorem of algebra, it says whatever your highest exponent is, that's the maximum number of solutions you'll get, right? So this is a quadratic, so the highest number of solutions is 2. Well, so to me it just seems weird that we would just get 1 real solution. So what I want you to remember is that that is called a double root. When you solve the actual quadratic formula, you do get 2 answers. They're just the same one. You'll end up factoring something and getting like x minus 2 times x minus 2. So your solution is 2, you just got it twice. Does that make sense? And it's a double root. Okay? So if your discriminant is positive, you're getting 2 real solutions. If your discriminant is 0, you're getting 1 real solution that's a double root. And if we have a negative discriminant, do you remember what kind of solutions we get? No real, but 2. I think I spelled it wrong. I did. Sorry. Please forgive me. 2 imaginary solutions. Okay? Let's remember real quick what those graphs look like. Okay? Obviously, this is not the only thing it could look like. All right? But I'm just giving you some examples. This is an example of 2 real solutions because the parabola crosses the x-axis 2 times. So that goes with that one. Okay? This parabola crosses the x-axis, or actually touches the x-axis 1 time. Okay? So that's what the graph would look like when we're talking about that one. And then last but not least, it might look like this because it doesn't cross the x-axis at all. Okay? Does that make sense? Any questions? Do you feel confident with all of these objectives? I tried to discuss this as we went, the most effective method. Okay? The most effective method if we're just solving by factoring would be if our leading coefficient's 1, or if it tells us to solve by factoring. If we recognize things that are the difference of squares or difference or sum of cubes, that would be the best way. If there's not an x term on either side, just an x squared term, using square roots would be the best way. And then completing the square, definitely if the leading coefficient is 1. What about the middle term? Does the middle term have anything to do with it being the most effective way if we're going to complete the square? We definitely don't want a fraction, right? Probably we also don't want a number that's odd either, do we? If it's odd, that's going to give us a fraction here. If this is an even number and our leading coefficient is 1, probably completing the square will be pretty easy. Okay? And then everything else we can do with quadratic formula. Because it's not the easiest or the quickest way, but it definitely works every single time, doesn't it? Real solutions or imaginary solutions, it can work every single time. Okay? You feel comfortable with these objectives for today?